Thank you, John. Hello, everyone. We are so happy to be here to tell you about our adventure in AI, which is called Liquid AI. So let me get started by asking our CEO, Ramin Hasani, how did it all get started?
Yeah, amazing. So, yeah, you guys hear me. Hi, everyone. Ramin Hasani, co-founder and CEO. We invented a technology called liquid neural networks. This technology is actually inspired by biology, is a new type of AI system that is more explainable, that is more rooted in the math that we understand. So if you build basically large systems of this type of technology, the system is always fully understandable, and we can really control. We have a lot of control on the design of these systems. They can solve problems in a very energy efficient way. How your brain is actually performing computation is actually, it doesn't consume the entire power of the United States to actually run, or train or obtain these models. These are very, very efficient models.
By the way, I've been running on a bar of chocolate today.
That's true. Exactly, so that's the amount of energy. And then, so everything started from Daniela's lab, where we invented the technology. Like, it's myself, Mathias Lechner, our CTO, who is not here today, with Daniela and Alexander, we co-invented this technology. And we tried over the last 7 years, we tried to really bring it at a stage where it can solve real-world problems. And we applied it in the space of autonomy. We applied it in the space of, like modeling, like building forecasting models for markets, for medical data. And we so soon realized that we have a technology that could be applied universally across kind of sectors. So we can apply to solve problems of sequential kind of nature. So if you have sequential data, like in the form of videos, audios, text, user data, financial time series, medical time series, and this kind of data, you can actually apply this technology and achieve state-of-the-art performance, do that in a very, very computationally kind of efficient way, and at the same time, running it on a math that you can completely understand. So these are the value props of the technology. So we decided to start the company with the idea of forming a new kind of foundation model for AI, because these are elements that are missing right now from today's AI systems. Explainability, efficiency, and performance that is considerably good on tasks that matter for us like day to day. We want AI systems to solve problems for us in a way that we can control them, and not just being like like today we have like productivity kind of tool systems, but we want to get them one step further to actually be able to solve problems. So as part of this panel, so we also invited some of our business development teams. So we have Nick Paliuka with us, and we have Louis Hunt, both of them from business development team, and we have our chief strategist, AI strategist there, Joscha Bach, the legend. And as you know, all might know Alexander already, as part of the founding team, and Daniela Rus.
Do you want to tell them about the name, why it's called Liquid?
Oh, yes. So maybe you can talk about.
Right. So, OK, liquid neural networks, right? So liquid comes from this idea of being very flexible and adaptable. One of the key properties of our own biological intelligence is our ability to really be flexible in what we know, but not only what we know, but to go beyond what we know and extrapolate and adapt very easily to brand new domains that we've never been trained on before. And this is actually one of the hallmarks for what I think of as truly intelligent systems. It's the ability not just to be statistical models trained on a fixed data set, but actually take that data and try to learn some generalizable patterns. So Liquid really comes back to that idea. It gets at this concept of being very fluid, very adaptable in many of the properties that it has, and this gives it some nice explainability features as well that Ramin mentioned. But Liquid itself is also it has this nice tie, not only the semantic meaning that is like a very flexible and adaptable system, but it also relates back to kind of the mathematical grounding of the Liquid model as well. There's a certain parameter in the Liquid model, which is called a liquid time constant parameter, and that's actually the real grounded origin of liquid neural networks.
Right, so let's not forget the hairy math that makes it all work. Okay, so I want to share a bit about how we think about solving the kind of problems Ramin referred to. Now, when we think about large foundation models that are being trained today, they're extraordinarily energy hungry. They cost a lot in terms of energy. They need huge server farms, and they cannot run on edge devices nor on company enterprise computers. And so how does Liquid AI think about this problem, and how does Liquid AI work towards more practical solutions as far as energy is concerned?
Yeah, so what we're building in-house is, do you hear me?
Yeah.
Yeah. So what we're building in-house is a developer package where we give enterprises access to this technology to solve problems. Now, these problems could be, domain-specific AI problems and generative AI problems. So in both kind of domains, we have been very successfully interacting with many clients already. And maybe Luis, you can talk a little bit about the business angle of things. But in terms of like how we are bringing value, is giving clients basically the opportunity to work with a private version of AI models, and best-in-class kind of AI models. So we give the technology all together in this developer package to companies to build use cases for. Now, the properties that I told you that you would get as a result of using Liquid AI's technology is the fact that you're not gonna need massive amount of compute to actually build AI solutions. For example, in the order, like for generative AI applications, you can build liquid foundation models as opposed to GPTs that are between 10 to 20 times more cost efficient and energy efficient in-house if you use the foundation of Liquid. Now, that comes with the explainability and all the features that I said. You can get the state-of-the-art performance. At the same time, when you actually take the technology and deploy it for inference and usage of the technology, you can gain between 10 to 1,000 times faster inference time. That's going to be like much cheaper to execute if you have like generative AI solutions. So in some sense, we're providing access
to lower carbon cost.
Carbon footprint, exactly. So development of very powerful AI systems today with the Liquid AI technology is possible with a fraction of the cost that is, the companies, the big tech is actually today spending. And that was one of the core properties of our technology. Maybe you can talk about a little bit about our business approach, how we are going and how we're looking.
Yeah, actually, so given this this extraordinary benefit that would put the technology in the pockets, basically on the enterprise computers of companies, how do you think about helping companies with the AI transformation?
Sure. Well, just the notion in general of this idea of a smaller, more performant, more powerful neural network model that companies can bring in-house, so the data never has to leave their premise, never has to leave their environment. The models never have to leave their environment. I know Daniela, as the director of MIT CSAIL, has been getting inbound requests for something like that for a long time. But it doesn't just stop there in terms of the genius of the brilliant AI scientists on the team, is that they've created a developer package that allows all those years of research to create these incredibly powerful, sort of groundbreaking models to allow the ML and AI scientists at enterprises all over the world to be able to build those kinds of models using the package in a way that's seamless, in a way that's easy to implement. And so now enterprises have the ability to be able to customize those models to their specific needs, whether it's in finance and whether it's an algorithmic trading firm that needs to be able to have sort of stock price predictions every half second with very high levels of accuracy, or whether it's another financial service firm that needs to be able to do anomaly detection or credit card fraud detection at a rate of 3,000 transactions per second or faster, or whether it's firms in biopharma and life sciences that need superior ability to do molecular sequence modeling. And so the use cases abound. It's a matter of focus now more than in prioritization, if anything. But we're excited to start to get this remarkable developer package and these models in the hands of more companies around the world.
Nick, I wonder if you can add to that and share some example business applications we're actually working on.
Yeah, so Louis mentioned a few of them. So within financial services, the types of time series data that is very common work really well with these models. And so a couple of the examples Louis mentioned, either stock price prediction or fraud detection, are really key value drivers. We're really trying to get away from some of the hype in the AI space and focus on problems that actually impact businesses. And so the best way to do that is to work directly with these enterprises and understand their problems, and then map the value of these models, which it may be efficiency, it may be performance, it may be latency, to those types of use cases.
Yeah, so that's so exciting, and I guess what I want to underscore is that it's not just about the fact that the model is smaller. The model is also more accurate, and so I wonder if one of you, maybe Ramin, you can tell us how are you thinking about the main challenges of improving accuracy? What exactly can we do in order to enhance the accuracy of the models? Because we don't want to have models that hallucinate, and especially for safety critical applications, we cannot have AI that makes mistakes. If there's an AI on a self-driving car and it doesn't detect pedestrians, that is a big problem. How are we avoiding that?
Yeah, great question. So it's the matter, whenever we want to bring a technology in real world, we need to ensure that the technology is reliable. It's accurate and it's reliable. Now, today's generative AI solutions are not reliable. The reason being, and as a matter of fact, they're not getting adopted because of this reliability issue, and that Daniela refers to as the accuracy and performance of the models, right? So think about how we are designing generative AI today. We train large neural networks on massive amount of data to predict the next token. Okay, so that means you're designing a hallucination engine, basically. That's the process. You're building a system to hallucinate. Why? Because you want to create a system that has, incorporate the knowledge of the world in that sense. So now, this is the first phase of obtaining a model. The model is a hallucination engine, basically, because it predicts the next token all the time. Then you go through a fine-tuning kind of phase. Fine-tuning phase is getting to this model to really fit the data that you want to see. These are labeled data. Fine-tuning process is basically labeled data. When you want to have an input, question answering, for example, is one of those schemes. So you want to guide this hallucination engine to answer some questions for you, right? So this is a process where you're trying to reduce the hallucination rate of the underlying technology, which is a transformer architecture. Now, transformer architecture itself is a feed-forward architecture. So if you have a feed-forward system, that means it receives an input and it generates an output, right? So there's no feedback mechanisms involved. So one of the things that our technology is actually bringing forward is the fact that we can now design feedback systems at scale, okay? So that means there's only that much that with a feed-forward system, you can actually guide the hallucination of a network. If you have a feedback system, like a human, that your brain is actually wired in a very condensed and recurrent way, and that allows you to actually control the hallucination rate much better. So this is actually how we are fundamentally trying to resolve the hallucination problem of these models.
Ramin loves to talk about the brain, and the company aspires to have an important role in AGI, in artificial general intelligence. And so I want to come to Joshua and ask you, what do you see as the scientific and technological challenges that will take us from where we are now to AGI? And also, do you see any specific milestones that we have to hit that will actually tell us that we're on a good path?
Well, if I could tell you how to get to AGI, Ramin would have all you sign an NDA first, at least. But so this is really an open question. It's also what makes this so exciting. What is the delta between the performance of the system that we are seeing and the capabilities of a human being in all relevant dimensions? And what we find is, for instance, our mind can hallucinate, but we can also make proofs. We can ground our perception in what we are seeing and what we are perceiving and in our motivational system. So we have a certain contextualization that is both given by our empirical access to the world and by our epistemology, by our ability to decide what's true, what's factual, and so on. And it's at this point not clear if the present architectures can solve this by scaling them up and getting better by introducing more and more data into the model and using more compute, or whether we have to build systems that are working more like our mind is doing, which means we are entangled with the world, we are always getting feedback from the world in which we are embedded in, we continuously adapt our architecture, and not just to the world, but also to ourselves. We basically are self-improving. And so I think one of the challenges is to reflect on and observe how biological systems are operating when they are solving problems and incorporate many of these ideas. But this does not mean that the present approaches are doomed. We just don't know, right? There's a lot of people which bet on the scaling hypothesis that you can basically brute force your way to a system that is so smart that it's able to help us building better, more elegant systems. We all know that the present architectures are too energy inefficient. We know that they need too much data to train, but we also see that they are unlocking capabilities that are very often surprising and amazing, right? So, for instance, there is no system that is able to demonstrate learning language like a human child by pointing at things, interacting with the world. But once we train an LLM up, we can give it a language it has never seen and put it into its prompt context, and it learns from much less data a new language than a human being could. So in some dimensions, these models are already superhuman. But in other levels, they are not human and intelligent at all. And so it's this very interesting gap now where we are able to develop tools that are super powerful, that we just begin to learn how to use and integrate into our world, into our lives, but that are not AGI. And the only AGIs are also not we as individuals, but it's a civilization that needs to span many, many generations before we can bootstrap ourselves collectively to the level where we begin to make sense of reality.
And as you think about the special properties of the liquid models, what are you betting on? What are you excited about?
What I find especially fascinating about liquid models is they do not rely on a fixed architecture where you start out with a predefined thing and use the perceptron algorithm is very powerful. But the main reason why everybody is using it for so long, since the 60s, is because it's also very simple to understand and very simple to build something that can train on it. And when we look at the way in which a brain is operating, it's much more fluid. And so if we go back to the drawing board, as Ramin did in his PhD and Daniela Rus did, we are discovering ways of making this more elegant. And while the mathematics looks on the surface slightly more hairy, you soon realize that, oh, it's actually a lot less work to do to get your system to do the same stuff as before. And so there is, I think, an important step towards systems that are more fluid and are more adaptable to the tasks and to the environment that they're in.
I mean, in traditional AI systems, the neuron is essentially an on-off system. Right? It's 0 or 1, and you have lots and lots of them, and some very basic math that makes information flow between them. But that's not how nature works.
Yes, biological neuron is not just a sum over a few real numbers that come in and a nonlinearity, and if then thrown in, basically. It's a little organism that is a reinforcement learner that can solve complicated problems in a continuous way. And by incorporating some of these ideas, we get a lot more powerful architectures. And it's basically what makes this very exciting from a research perspective to be part of this.
You know, John is not here, so I think we can keep going. So what is next for Liquid?
Yeah, so, I mean, one of the things that I want to do, the technology itself is like one of those, out of the box thinking kind of ways, and it also induces hype. We are also aware of this thing. But one of the things that at the company we've been trying to keep our heads down, and if you look at our accounts, like what we are announcing in the social media, it's basically like very minimal kind of information we are releasing. We're just absolutely going to bring value, and you're making this thing real. And I think this is one of the things that at the company, the last year we've been very silent, and we have been like operating on a, delivering value to our clients, and this has been very, very rewarding journey for us. Like we have been, one of the few AI companies that have already interacted with 50 plus kind of Fortune 500 companies which are already using the technology, and they're in negotiations with the company to actually integrate this technology in their work. And we are just keeping our heads down and executing and bringing the value of AI to enterprises.
Well, since John is not here, I'm sure that everyone will want to be very clear on what the company offers. So let's say I'm a new customer looking to expand my AI know-how and looking to bring foundational models in my business. What can Liquid AI give to me?
Yeah, maybe so. 2 levels, right? Level number 1 is it gives you a comprehensive developer package and infrastructure around that to develop and deploy in-house liquid neural networks that are capable and private. So capable in terms of being highly accurate, but private being in terms of, small enough that you could have your own internal massively performant AI model entirely in-house. And then on the other side, Liquid AI offers the actual models themselves, not only a developer package, but actually the models and the infrastructure around those models to, number 1, train, fine-tune, and deploy on your own data as well. So you kind of have these 2 sides of the coin with what we offer to our customers. It's on one side is a very low-level developer package. On the other side, the models that can actually augment all of those functionalities for customers.
Well, thank you for the opportunity to tell you about our exciting adventure. And thank you to our wonderful panelists and leaders in AI.
Okay. In just closing, is there an ecosystem that St. Louis was Silicon Valley before Silicon Valley? Detroit was Silicon Valley before Silicon Valley. Actually, Buffalo was offered the car industry and the plane industry, and they said no, and it went to Detroit. Buffalo could have been Silicon Valley. And in the 1960s, there was a list of 2 cities that weren't going to make it. Detroit, and we know what happened there, in terms of economics. I really appreciate, Randall, you have been propping up Detroit, doing some amazing stuff. Boston and Detroit were 2 cities that weren't going to make it. Boston's done okay. We've reinvented ourselves. Could what Liquid has created create a seismic change of the geography of where innovation and economies and opportunities, say Silicon Valley, watch out, and the rest of the world, watch out? Is there an opportunity? Just go. One comment on this. Go, each of you.
I still live in Silicon Valley because there are a lot of ideas that exist there. And while I loved Boston, I felt that AGI was always a little bit further in the future in Boston than it was in Silicon Valley. Not as much as in Berlin or Zurich, where it's basically never going to happen. Yeah. But I think that this is an extremely important place. MIT is not necessarily always the place where you build products. It's the place where you build the ideas that will drive the products. And this is the amazing value of this place, that you have people who actually think, who do not just try to apply what others have thought about.
You're a little theoretical. I'm asking, can Liquid change things? All right, Liquid. Business development guy. Can Liquid make a difference?
I think that whenever you have a foundation of talent like you have at MIT, and then you have an incredible community at MIT, as well as folks that help to foster and cultivate that community. You, John, Dave, just extraordinary, both in terms of building the community, also supporting companies like us. And so I think there's the
transistor, going from tubes to transistor, that created a new ecosystem. I'm saying you guys are onto something big. All right, what do you think? Kid who just graduated with honors from Duke in computer science, didn't do Latin or Greek, and then with distinction from HBS. What do you think? You're you don't have gray hair yet.
No, I do not. A little bit, but innovation can happen anywhere. MIT is a breeding ground for innovation. Boston is as well. So I'd say innovation can happen anywhere, and we are just trying to put ourselves in the position to be people innovating. And we have a great team of researchers led by these 2 and this one, and a bunch of people out of MIT, but a bunch of people out of other universities that are also really. All right.
You 3 have done good, but co-founders, or tri-founders, can you say how can Liquid create an ecosystem that will change the vector of society? What do you got?
So very simple from my end. I think that the company is not done innovating. I think that we still need a ton of innovation to get to AGI, similar to what Joshua said. I think that not only we need innovation, I think we need out-of-the-box thinking. It's not just about implementing existing ideas. We need to reinvent brand new things and go back to first principles in order to do that. And there's no better place, in my opinion, than the MIT community to nurture that.
All right, CEO, what do you got?
Yeah, I mean, we could always like praise ourselves all the time, but we can also like learn. So one of the things that we have actually achieved at Liquid is like one of the few companies that we are having massive amount of superstars from Stanford joining a Boston headquartered kind of company. So this is like one of the
it's like sea turtles.
Very,
people
very
going out, coming back.
It's like the other way around, So, and I think this just comes with the fact that it is not all about, like, of course, you have a great idea, but you need to have like a plan. How do you want to execute that plan and stuff? And I think everything, like for us, is like we have a foundation model that is, I mean, as I said, I don't want to contribute to the hype around everything. So because everything I say, it might actually be interpreted like that. But as I said, we're keeping our heads down. We're attracting the most important talent in the world that are actually innovating. Like you can see, we have 30 people at Liquid right now that they're the brightest minds on earth. Like this is like such an energizing kind of experience for myself as the CEO of the company. That surrounding myself like with amazing people that can contribute to this core. That we want to build an AGI that we can understand. We want to build AGI, and this is going to be this company that is actually going to, like, this is what I believe, that we are onto something crazy here. But it is going to take time. It is going to take talent, and apart from that, there is also the support of Silicon Valley became Silicon Valley because there are a massive amount of capital and business kind of surrounding the Stanford community actually went into the whole thing. So I think that's the part that we have to get a little bit moving. We have to be a little bit more risk-taking as people of Massachusetts, I would say. And that's the part that I think we've been successfully igniting something here, and we are on the verge of making it even more. But yeah, bringing both business and the technology thing together to make it happen.
All right, in closing, she's a MacArthur Genius Fellow, but forever she will be known as the TED homepage speaker that launched on Friday. The answer I was looking for, which none of them got, was we're going to be oxygen for a lot of ventures. And people are going to say, look what happened because we created something on the other side of firewalls, on robots, on using less energy. And these guys are just built something that I'm so excited about. All right, Miss Moderator, what do you got?
Well, let me just say that ideas, and especially out-of-the-box ideas, change everything. And Massachusetts and the Boston area has 100 universities with so many bright minds who can change everything. And so I live in Boston, and I believe that this is a great place for AI and for the next AI revolution.
All right, get off.